In this session, you can just see it here. You're given a state diagram. Now, personally, I'm more accustomed to the term state transition diagram, but because that it's a fuller, longer, obviously, label, but it's more complete because it's more than just a state diagram. Now, like here are the states. We have like 3 nodes, 3 states now: Q1, Q2, Q3. They're the labels of your 3 states. But if you're calling it a state transition, like these arrows, they're your transitions, and they could correspond to incoming signals. Right? Depends on the context. It depends what to what your application is, to what you're applying the finite automaton model to. Right? So these arrows usually just called transitions. Right? So states, 3 states, and all these arrows, they're the transitions. So state transition diagram. But that's a bit of a mouthful. So some people just shorten it to just simply state diagram. Okay, and Sipser certainly does that a lot. And so he just tends to talk about state diagrams. Okay? But remember, that's a shorthand for this fuller state transition diagram. Okay, so now we'll introduce some more concepts, some more terms that are useful for talking about state diagrams. And I'll use the Sipser term. Okay. So have a look at this and read a bit here. What have we got? So obviously, just by visual inspection, we've got 3 states, right? Labeled Q1, Q2, Q3. Now you've seen this sort of thing before. Now this is new. 2 circles, a node with 2 circles. What does that mean? We'll come on to that, but I can label that kind of state that you represent with 2 circles. It's called an accept state. Accepting what? Later, right? But if you see 2 circles like this in a state diagram, that particular state, in this case Q2, is called an accept state. Now, what that means and why, we'll do that later. Don't worry about it, right? So other than that, everything else is familiar, I think, because we did it 2 sessions back for the door controller. Okay? So looking at this as a graph, so we have the nodes are states, the edges are transitions, right? Labeled transitions. And what's the label on a transition? It's an input signal. It's one of the symbols of the set of input signals, if you think about it. All right. Now, so we talked about the accept state. That's the one with two circles, a node with 2 circles. Now, there's another kind of state in this context called a start state. Now, you have to start in a finite automaton. You have to start in a given state. You have to start in one of the states, right? And that state is, well, usually, but you have to start somewhere, right? So let's say you start in one state. That start state is called just that start state, right? In this case, it's Q1. And how do you know it's Q1, not Q3 or Q2? How do you know the start state? Because there's an arrow coming in from nowhere, right? And when that happens, so this arrow here has there's no node here, just disconnected. So this arrow here is not a transition, right? It's just an arrow telling you, hey, this node here is the start state. So you could look on that arrow as the start state indicator, something like that. Right? So you look at a state diagram and you go looking for the disconnected, if you like, arrow, the arrow coming in from nowhere, and it points to your start state. So you look at this and you'd know immediately that Q1, that state, is your start state, and your accept state is this one, right? Right, now you know these arrows, they're called transitions, right? So we've got nodes and transitions, or states and transitions, or in graph terms, nodes and edges. Okay. Now we start getting more into the very use. What are finite automata used for? So you have this device, this machine, this automatic machine, this automaton, which is that's what an automaton means in a sense, the ordinary sense, ordinary English sense of the word, an automatic machine, an automaton. Now, usually a sequence, some kind of input string of symbols. In this case, we're talking binary symbols, but they could be letters or whatever. Some kind of a sequence. Over time, a sequence of signals goes into this automaton, into this machine, and the machine looks at each symbol one at a time, one by one. Okay, and depending, so this would be then like a signal. Going in. So the first signal goes in, and this machine, the automaton, is looking at this sequence of signals coming in, one by one. First this one, then this one, then this one, this one, and from left to right, let's say. Okay. So this automaton, this machine, in fact, is processing this sequence of signals, this string, in other words, sequence of signals, a string. Right? So this automaton is processing in some sense. I'll explain what that means in a minute. This automaton is processing this string of symbols. So this string of symbols goes into the automaton, and then the automaton makes some kind of decision. And we're going to keep it simple for the moment. So let's this simple automaton. It looks at it processes. It looks at its input string. For example, 1, 1, 1, from left to right. Processes each symbol one by one, and once it's finished the processing, it outputs a decision, in a sense, of two kinds of decision. One is accept, and the other is reject. Accept what and reject what? Well, this sequence of signals, it accepts it or it rejects it. And what does that mean? Again, wait a while. Okay, it'll all crystallize after a while. We're just setting up the terms and the label, the technical terms. Right. So summarizing a little bit. State diagram. Okay, in this case, three different states. The arrow coming out of nowhere, it points to your start state. So your automaton starts in state Q1. Right? You know that because of this arrow. If it has two circles, that particular state, in this case Q2, that's called the accept state. Right? Now you may be getting suspicion. There's some link between this state, the accept state, Q2, and the decision that the automaton makes once it's finished processing the input stream. Okay, and you'd be right. We're not there yet. Right? Okay, so this automaton, what does it do? It processes an input stream, and then once it's finished processing it, it outputs a decision, and the decision of two kinds. Either the automaton accepts this string, or it rejects this string. And you may ask, for what reason? On what basis? Why? Okay, well, that's for later. Okay. Now, for simplicity's sake, we will just have two possible outputs, right? Accept or reject, and we can complicate things later. But we're trying to understand the basic the basic ideas first, right? We're more concerned with the didactic aspects of this subject right now than completeness. I lived in French culture for quite a while. They tend to be the other way around. In mathematical terms, American mathematicians tend to get very frustrated with French mathematicians. The French are very particular. It's just part of French culture, French mentality, that the appearance of things often is more important than the substance. And that mentality, that value system, it just enrages